So, as most of you haven't actually used it yourselves, I've got just a quick introductory demo, which will also let me explain some of the terminology I'll be using. Now, if things get confusing, which they may well, please feel very, very free to ask questions immediately. I will try to keep looking over at my second screen, which has the questions on. If I fail to look at them for a while, Amanda will interrupt and ask me, but please do feel free to interrupt at any time. Okay, so in brief, the async feature of C#5 lets you write asynchronous code as if it were synchronous code, pretty much. It doesn't perform any true magic, but it takes away a lot of the drudgery of asynchronous code, which usually involves, as Eric Lippert puts it, turning your thought process inside out. So instead of having a sequence of events in your code that goes from A to B to C, you would say start doing A, and when that's finished, come over here, which would usually be a different method, and then you would keep going with B, and then you would say when some asynchronous task involved in B has finished, then could you launch into C? And doing all of that with decent error checking is really, really hard. Fortunately, the compiler is very good at doing the grunt work of it, and that's what we're going to be looking at tonight, exactly what's involved. But from the user's point of view, this is the kind of thing that it would look like. So I have a little program here, just a console application. Most of the examples that you may have seen on videos will have involved WPF or Silverlight or Windows Forms. I'm a big fan of console apps, so everything tonight is a straight console app, which also allows me to show the difference between using threads and asynchrony, because they're not necessarily the same thing. Now, we're going to start our main method, and all we're going to do, the point of this exercise, is to load two web pages, stackoverflow.com and google.com, just their main pages, and then work out the size of those pages in characters. Very straightforward stuff, but we will be downloading both of them at the same time, and while they're actually downloading, we'll be able to keep going with whatever we want to do normally on the main thread. So our program starts off by calling into our load pages async method, and then it just shows that something is still running on the main thread. That's where you might put anything else you want to do while you're waiting for the results. Then we're going to get the result, which is the total of the size in characters between the two things. And then we're going to print out the total size of the result. Just to answer Booker's question about this sounding like a switch statement in terms of doing one thing, then doing another, then jumping on, we'll see later on that indeed the compiler basically builds a state machine which is a bit like a giant switch statement. So let's have a look in load pages async, and the first thing that we notice is that it's declared with the async modifier. This is a new modifier to C#5, and it tells the compiler, and more importantly anyone reading, this method is asynchronous, which means it has to return either void or a task of T. I'll explain about task of T in a minute. So it either has to return void or task of T for some particular T, and within an asynchronous method there can be await statements. So let's have a look at what we're doing within this. First, we're using a new extension method on web client, because the CTP doesn't actually change any existing classes, but it adds a bunch of extension methods. For .NET, whatever this comes out in, this would probably be a normal method on web client. But it's going to call download string task async, which is a method that in turn returns a task of string, and it's going to give the URL for that. So we've got one task of string for Stack Overflow task and one task of string for Google task. And the idea of a task of T that I mentioned before is it's like a future, as it's known in some other programming languages. It means something's going on, or maybe something's ready to start, and at some point in the future there will be a result. And you can ask a task for its result, in which case we will block the current thread until that task is ready to give its result. Or we can say, when this is finished, do something else, which will be very important for us later. And we can find out whether it has already finished, whether there have been any exceptions, whether it's been cancelled with a cancellation token, all kinds of things like that.
Hey, John.
Hey.
Someone's asking, is there any point declaring it async if you're not using await?
There isn't, and in fact, there may be some particularly bizarre cases where it would be useful, but if I try to compile this code without an await statement, we'll get a nice error message saying this async method lacks await operators and will run synchronously. Consider using the await operator to await non-blocking API calls, etc., etc. So there may be some very strange edge cases, but in general, no, you will await something within any async method. Otherwise, it would be quite strange. I guess the one situation where you might have it is, I'm just debugging something, I'm just going to comment out a couple of lines, and we still want it to behave roughly the same, even though temporarily we're not awaiting anything. But yeah, in 99.9% of code, by the time you check it in source control, it will have await statements or await expressions in.
There are some follow-ups to that. Do you want me to? Why did we not have to await load pages async?
Right. So an async method is a perfectly normal method as far as the compiler is concerned. It just returns a void or task of T. We could have, if we'd made main itself async, we could have awaited load pages async. But you don't have to await an async method, and what you await doesn't in turn have to be an async method. Both of those will happen quite often, but not always. Amanda, if you could keep shouting out any questions that come up, seeing as none of them are showing up for me at the moment.
Oh, they're not. So you have one more. Is async method required to be static?
Absolutely not, no. Probably all my examples will be, but it certainly doesn't have to be. It's just that I'm not writing a proper, full, object-oriented program at all. I'm just trying to demonstrate the async features and nothing else. So we could have done, if I stop that from being static, I could have done new program .load pages async. That would have been absolutely fine. Okay, so we've created two tasks, and then we hit the first await statement. Now, what this is going to do, this could take one of two routes. It can either return immediately because the task hasn't completed yet, and return a task event to the calling method, and all of this effectively keeps going in the background. Or if Stack Overflow has been really, really quick to respond, then we can say, well, we already know the result of that, we'll keep going. Now, the sort of interesting case is the first case where it hasn't yet finished, and we want to keep going in our main thread, but in some senses pause this method until the result is ready. And that's exactly what await does. It just says, I want to only keep going when this has finished, where finished includes cancellation or an exception. Until then, my caller can have a task representing the operation, the overall asynchronous method, but just call me back when I can keep going. So we're going to do that for Stack Overflow, then for Google, and at that point, when we've reached this line here, we've definitely got the results, so we can then just return. Now, the interesting thing here is the return statement is returning an int, even though the return type of the method is task event. So this is one of the interesting things about an asynchronous method. You return a t for some t, and your method is declared to return a task of t. Or if you don't have any return statement at all, you would declare it as a void method. It's a little bit like, and in fact there are significant parallels with an iterator block where I do static IEnumerable string get foo, and I can do a yield return of different strings. So here again, the yield return statement returns a string, even though the method returns an IEnumerable of string. And in fact, a lot of the mechanism behind load pages async and asynchronous methods in general is the same as it is for iterator blocks. In particular, if you were iterating over the result of get foo, you would effectively pause before the method was used at all, and then when the caller called move next for the first time, you'd execute this line and pause again. Then when the caller called move next again, you'd end up executing this line, and then a final move next would get to the end, at which point it would say there's no more data. So that's very, very similar to do some work and then let the caller do whatever it wants to do some more work, etc. It's just that instead of waiting for the caller to say, I'd like the next one, please, we're waiting for something that we've started to come back to us. I should probably run this code just to prove that it does actually work. So we can see on the main thread is the first thing to be printed, then we've got the results, and then we're printing out the total size. So what's happening behind the scenes is that this is starting. As soon as we hit this await expression, this is all happening on the main thread. We're calling load pages async on the main thread, and at that point, the load pages async method will return a task event to the main method. We can then, on the main thread, print out this debug statement, and then when we get called back, well, on the main thread, we're going to wait until that's finished by just using the result. Result is a blocking call of task of t, so we don't get to see anything else happening on the main thread until we're done. So clearly our code has to execute on different threads for load pages async. And in fact, an IO completion port will probably be responsible for triggering us and waking us up again when the web client has got some data for us. So this will run on a thread pool associated thread. We'll then go back to sleep effectively, wait for Google to come back, and then at that point, when we return from here, the task that we originally returned from load pages async will be told, hey, you've got a result now, the main thread will unblock, and we can print out the total size, and we're done. Okay.
Hey, John, you've got some questions popping up.
Right.
Does the Google task execute after the Stack Overflow task has completed?
Good question. No, in this case it doesn't. Now, in general, there's a task-based asynchronous pattern, which is a new thing that Microsoft have come out with. There's a white paper behind it. It might not be called that in the future. It might change significantly, but it's based on hot tasks, so tasks that are already running. So when we call download string task async, by the time that returns, that has created and started a task to do the work of calling Stack Overflow, and likewise here. So we get to this point, and both our tasks have actually started. We then wait for one of them to finish and wait for the other one to finish. Now, it's quite possible that Google will have come back before Stack Overflow has come back, and that's okay. That just means when we have the await Google task, the compiler-generated code will say, hey, that's fine, you've already completed that, you can just keep going. You don't need to go to sleep and be woken up again immediately, we'll just keep running. Now, if I had, instead of having these two tasks up front, if I'd done await, it would be perfectly reasonable to do that, and the same thing for the Google one, but then it would have waited, so let's just actually complete the code there. If we didn't have these, this looks similar code, but it's not. In this case, we wait for Stack Overflow to finish, then we move on to the next thing, which waits for Google to finish. And that's clearly not a great idea. We're not doing anything in parallel. Whereas with our original code, the these two tasks are running in parallel. Not two different threads, because they've started stuff that the tasks themselves are effectively the web. So we're waiting for Stack Overflow to come back to us, we're waiting for Google to come back to us. We can do that without taking any threads at all, and then as soon as the I/O completion port fires to say, hey, we've got some data, then we need a thread to say, let's wait for Stack Overflow to come back. Oh, we've got that, we'll decode the data into a string and move on. Any more questions at this point?
Yes. Which thread will display got the results? Is it the main thread executing?
This line here will execute on whatever thread is called back, either by Stack Overflow task if Google task is already finished, or the one that calls back into Google task. It will be a thread pool thread, possibly but not necessarily associated with the I/O completion port. It depends on exactly how web client works. But it will definitely be a thread pool thread, because our main thread at that point is blocking. So if, now this will be interesting, I'm not very good on the debugger support for tasks, but we'll see what we can get to. Hopefully, by the time this hits the breakpoint, we will be able to see, so we have a call stack there. If I go and see the Windows parallel tasks, nothing there, parallel stacks. Oh yeah, okay, we can see an interesting thing here. So we have one thread of program main, which is in line 16. Okay, so that's waiting on it. And we have another thread over here, which is in load pages async, this one. So we can see the actual two threads here. I'm not sure what this one's doing, but it's probably just a one that's in, yeah, it's in external code. So we've got two distinct threads here, one doing our async method and one doing our main method. I should point out at this point that asynchronous code doesn't always involve extra threads, and in particular, there's a big difference between asynchronous execution and trying to run multiple tasks in parallel on the local box to take account of multiple cores. So even if you've only got one processor, it still makes a lot of sense to use asynchronous things, particularly if you're going to do asynchronous I/O, whether that's to disk or to the web. Any more questions?
Yeah, you actually have quite a few popping up.
That's fine. That's fine. The better we can all understand this bit, the better the rest will actually.
Let's see. Once we use task, will there be any difference if we use download string instead of download string task async?
Okay, so download string does it all synchronously, so that wouldn't return a task of string. That would just return string, and we'd be stuck waiting. If we did that in these two lines are executing in the main thread. So until you hit the first await expression, you're executing as normal, perfectly normal. It'll still be in the compiler-generated weird code that we'll see later, but you are still executing in that main thread. So yeah, if we use download string, we wouldn't get a task. It would all be synchronous, and there'd be no point in it being an async method.
How do you manage timeouts?
Timeouts you could probably set on the web client itself, and let's see whether we can just set a timeout. Maybe not for web client itself, but in general, for a task, you could. There may even be something on here that says. No. In general, you would be able to set timeouts for anything that supported timeouts, and you could potentially have another task which just effectively did a sleep and woke up when you wanted to time out, and then you could wait on your two tasks, the one that was actually trying to do something useful and your timeout task, and you could say make the timeout one throw an exception or give a particular result. And one of the nice composition features of tasks is you can say, tell me when any of them have finished, or tell me when all of them have finished. So if you said, I've got two tasks, tell me when any of them have finished, then the timeout task would finish before the web download, if that was a particularly large download or whatever, so you could keep going at that point if you wanted to. So in short, there are ways of managing it. Obviously, the more you think of that sort of thing, the more complicated things become, because there are different routes that things can take. The async stuff hides a lot of the boring complexity from you, but you still need to be able to think in asynchronous terms and think that multiple things can happen, including a timeout, and two things could time out at the same time, or anything like that.
I thought that async methods were compatible with WinForms, but if I understand it correctly, as the thread which will be executing the remainder of the load pages async on a thread pool, it won't be able to touch any controls. Do we still need to worry about using control.invoke?
Great question. I really should have mentioned this before. So in this case, we're in a console application which has no particular context of a synchronization context. It doesn't really care where any new tasks will be run. If we were running in Windows Forms, then when we got back to here, when we got to the assignment bit, after await Stack Overflow task had finished, we would indeed be on the WinForms UI thread. Same if you were using WPF. Basically, the trickery behind await can pass on the context saying, when you call me back, I need to be called back on this thread. And that does indeed let you use all your Windows controls, and that's one of the nice things about async.
Which thread does the web client.async calls get called from?
So these two methods themselves will be called from the main thread. So if I stick a breakpoint here, then, well, let's see, we will still be on the main thread. Yep, you can see there's an interesting bit of external code there, which is the compiler-generated gubbins, basically. But you can see we've got a stack trace that includes main. We're still there, but if I do the same thing on the next line, then by the time that returns, oh, we've got a nasty exception. Okay, let's close that and restart. Okay, so now Stack Overflow has come back, but look, we don't have a stack trace anymore because we're now back in the thread pool thread instead of in the main thread. So as far as the first await is definitely in the main thread, if the first await has already finished, then you'll keep going in the main thread. It keeps going until it knows, hey, I need to wait for something to happen, but this is an asynchronous method, so I want to let that just happen in the background, and I will return the task representing the rest of this method back to the caller at that point.
Let's see. So the download string task async has to block its thread whilst the download action completes. Some of these are out of context, obviously.
Download string task async doesn't really have its own thread. Well, I'm assuming it could just start its own thread and do a synchronous fetch within that thread. In fact, it's going to be more sensible than that, because part of the point of async is to mean we need to use less threads, fewer threads, in order to do the same amount of work, because a lot of it can be done completely in the background without taking up a thread, and it would use I/O completion ports to signal when data had come back from the website. But a lot of that is managed by the tasks parallel library and by things like web client knowing what to do. So that will all be handled for the most part for you without you needing to worry. But you can sort of think of it as starting a new thread, doing everything synchronously, and then triggering the task to say, I'm done now, at the appropriate time.
Okay. John, you have like probably 15 questions lined up here. Do you want to take all these, or do you want to continue on with your demo? I just want to check in with you.
Oh, I can see them now. Right.
Yeah.
I can see some of them. Right. I will just skip down them briefly. Right. So looking at these quickly, async doesn't change its signature in any way. It still returns task of T. Yes, as far as the compiled code is concerned, if you look in a DLL that's generated, it will still return task of T. Plans for Silverlight and phone support, I don't know. Just as a reminder, I don't work for Microsoft, so I don't have. Well, it's a serious point that I don't know anything that isn't public. I would be absolutely staggered if there weren't any plans for something within Silverlight, and I would love it in Windows Phone. But yeah, I don't think anything's been announced yet. Right, why is the syntax not async return by analogy to yield return? I guess it could be, so that would be putting it like that. I think we'd still probably want the async modifier on the method just to make it clear immediately that you see the thing. And at that point, well, do you need it on there as well? It's trickier. In the case of yield return, that's all that signifies that it's an iterator block. It's possible that the C# compiler team thought that this was a mistake and they should have had static yield there. I don't know. It is what it is. What happens if you put console.writeLine immediately before the await statements? In this case, they would execute in the main thread because we hadn't awaited anything yet. If we put one between the two, then that may or may not execute in the main thread. Almost certainly not. It would probably execute in the thread pool thread. Is the async type a new method to sync threads using join in previous C# versions? There isn't an async type. It uses task of T, which has its own primitives or its own operations to allow you to block for things. But yeah, there isn't a specific async type. If you're using identity impersonation, do tasks execute under the same identity? I have absolutely no idea. I would imagine they do. Could you give an idea how async methods can be called before the era of C# 5 in 4 or in 3? You could call them, so if someone had built something using this, but you wanted to call it from C# 3 or 4 code, you could call it as normal. You would get a task back. You would just have to manage the asynchronous nature of it yourself. If we did Stack Overflow task.result, how would that be different from await? Okay, that's a great question. So the question is, if we change this to Stack Overflow equals Stack Overflow task.result, right, this is a blocking call. So because we haven't hit any await calls yet, we're still in the main thread, and we will stay in the main thread and just sit there until Stack Overflows come back. Whereas with await, we will return a task immediately. Things can happen in the background, such as printing on the main thread, and life can go on. So that's the difference. Await isn't blocking as far as the caller is concerned. It's blocking within the async method, but it's not blocking for the caller. Is there a way to wrap a... Sorry, I've missed a couple. If one await task never returns, what will happen? The asynchronous method will effectively, if you think of it as being paused, it's not actually taking up a thread, but it's sort of paused, it will never progress at all. And probably, eventually, you'll be awaiting the result of that, and that will never progress. Just as if you synchronously wait for something that never happens, your program isn't going to make any progress. Is there a way to wrap a normal method in some lambda that returns a task of T? Absolutely. There's something in task X, which is a CTP library extension set. I think we could, yeah, task X.run, and that takes an action. So that would return a simple task, which is sort of, you can think of task as task of void, except that's not valid. And there are other things that will run a func of t and return a task of t. You can do this without the CTP, and indeed we will later, by doing task.factory.start new, and so we could do start new of int, for example, and do something that returns 4. Yeah. Like that. So that would return a task of int, and then you could await that, etc. If we're writing our own version of download string task async, what special things do we need to do? Tricky one. So it depends on if you want to use the I/O completion ports and things, it could get tricky. Chances are you're going to use existing async bits that Microsoft has already exposed. So you could use the stream.beginRead, etc. It would be things like that. Other asynchronous mechanisms where you get a callback, and we'll see later how we can return a task of t from that. At least I hope we'll see that later, but we are halfway through. Threads created and coordinated by the UI thread. Does the UI thread remain responsive? I think I've covered that before. So if we were within a WinForms UI, we would start load pages async on the UI thread, but this would be cheap. We would get as far as here. We would return back to the event handler, the message pump, and then when we got a result from Stack Overflow, we would then effectively do a control.begin invoke, you can think of it as, to say, could I run a bit more, please? So yes, the UI would remain responsive. Okay, I'm going to ignore the rest of the questions for the moment, as the next one to see was, maybe we should let John get a chance to keep going.
Cover your original demo?
Yeah, so this is before the first real example. This is the only project within the solution that refers to the AsyncCTP, and I'm now going to close it. So the idea for the rest of the session is that we will build some of the AsyncCTP ourselves. We won't be building the C# compiler bits, we'll be building the stuff that the C# compiler uses. Now to introduce a compile time error. So, one thing that I wanted to highlight here is the 3 different aspects of async. We have whatever calls the async method, which I'll keep calling the caller method. We have the async method itself, and then we have the awaitable method that is being called to start with, or the awaitable object, the thing we're going to await. And you can think of these as 3 very different things. The caller method gets to go off and do whatever it wants. The async method is what ends up getting paused effectively, and the awaitable object gets to go and do its stuff, make a web request, wait for the network to come back, or maybe it's doing something CPU intensive on a different core, doesn't matter, but that's a task, an awaitable thing. So those are 3 very different things, and between the 3 there are 2 boundaries. There's the boundary from the caller to the async method, and that's the boundary that returns the task of t. And then there's the boundary between the awaitable thing and the async method. Now I keep using the word awaitable thing instead of task of t, because although the asynchronous method itself has to return a task of t, so at this boundary point between the caller and the async method, you are limited to either void or task of t. You're not limited in that sense in the boundary between the async method and what you're awaiting. Which leads us to our simple awaitable. So this bit, excuse me, is actually in the C# spec, the new version of the spec, which is again downloadable. If you search for MSDN Visual Studio Async, you'll get to the Async CTP homepage, which has loads of videos, the CTP to download itself, and the task asynchronous pattern documentation, and the C#5 spec addendum. And it talks about these calls here: GetAwaiter, BeginnerWait, and EndAwait. So in our attempted program, we're going to call an async method, and you'll notice this is returning void. We're not going into building a task, but we're going to create a simple awaitable, nothing to do with task of T, but we're going to try to await it, and then we're going to write out the result. Okay, we're not starting any new threads. It'll be several projects before we get to start any threads. We're taking it one step at a time, but in some senses, this should work. And if we were using AsyncCTP library.dll, this would build. As it is, when we try to build it, we get cannot find task-related types. Are you missing a reference to AsyncCTP library.dll? And missing compiler required member blah dot void async method builder dot create. So before we address those errors, which are to do with this boundary, the caller to async method boundary, let's have a quick look at what simple awaitable does. So if you have an await expression, whatever you await has to expose a GetAwaiter method. And the type, whatever type is returned by GetAwaiter, in turn has to have BeginnerWait and EndAwait. And it basically has to have something like this as its set of signatures. The BeginnerWait method has to return bool, and it has to take an action, which is actually the continuation. The EndAwait method can return whatever you like, and it's no coincidence that we're trying to have an int here, and we're trying to return an int from EndAwait. So the idea is a task of T's awaiter would return a T, and a simple task would have a void EndAwait. So I'll explain what the return values and things are to do with later on. But basically, the compiler-generated code is going to call GetAwaiter and then call BeginnerWait on the result. It might then call, in fact, I think it always does call EndAwait to get the result. It's got to. That's the only way it can get the result of the asynchronous operation. But there's the idea of an awaitable and an awaiter in exactly the same way as we have an IEnumerable and an IEnumerator. Okay, so that doesn't compile, so we'll unload this project again. Bye-bye. And try to introduce some compiler support. So most of these projects tend to have exactly the same code that the previous project had, just with a bit more stuff. So our simple awaitable looks exactly the same. Our main program looks exactly the same, but this time we have some compiler support types. So we saw before the error saying it wanted a void async method builder, and we've given it one. Now we have to be in this particular namespace. This isn't documented as part of the C# spec. I had to sort of mess around experimenting before I could get it. But it has to be a public struct, and there has to be a public static void async method builder create method that returns one of these things, and it's got to have a set completed method. Excuse me if I start getting hoarse over time. I've just finished my water. Okay, so now that we have a create method, we can see it compiles. Hurrah! And now if we set this as the startup project, I'll just run it to start with. So what we're expecting to happen is we will call into async method, and we wouldn't expect anything odd to happen, as in we're still beyond the main thread for certain. We haven't actually written any code to go onto a different thread, but whatever happened, we'd expect to be on the main thread at the moment. We're then going to await this result, write out the result to the console, and return. And sure enough, we get a result of 5. So that should be unexpected. But we can put some breakpoints in. So in particular, set completed we can see that's actually never being called, which is kind of odd in itself, but it is required. If I try to build without it, it says I wanted a setCompleted method. Okay, so I suspect that only gets called by the compiler code if we return true from this BeginnerWait, which leads us to work out what BeginnerWait is about. So the idea of BeginnerWait is that the compiler passes in an action, the continuation, which represents the rest of the method. So in our case, it represents this assignment here and console.writeline y and return. So we're getting an action that means that. And the contract that's specified in the spec says if BeginnerWait returns false, that means the asynchronous task was already done, really, so we can just return immediately. We won't execute the action. If BeginnerWait returns true, it means this could take some time. I have subscribed your action as a continuation. Could you just return now, please? And then endAwait is called, again, by the compiler-generated code to get the result either from the action. So the first thing that the continuation that's passed in here will do is call endAwait to get the result. Or it gets called if we return false, as we do here, to say, okay, you didn't have to wait for anything. Could I just return the result now, please? Okay, let's have a quick look at questions before I move on. I'm not going to go in just seeing the, is it possible to show an example of a grid on a form and loading its data using async? I'm not going to do that tonight because I'm so short of time. Maybe another time. Can a void async method return a non-generic task in addition to void? Yes, it can. So it can just return task. If it returns void, is it possible to wait for it to finish? No. Because there's nothing, you don't have a handle on that, the task representation for that method. Why isn't there something like an IAwaitable interface to implement in simple awaitable? Well, if something had to be awaitable in an interface, then the CTP would work for one thing, because we can use extension methods. The expression GetAwaiter on the awaitable method, on the awaitable X, has to be valid. So x.getAwaiter has to return something, an awaiter that's got a BeginnerWait, etc. We can implement that as an interface, but then no existing types get to do it. But we can also implement it as extension methods, just like all the link methods are extension methods on IEnumerability or IQueryability, etc. Likewise, we could have, it would be slightly more reasonable for the awaiter thing to be an interface, but again, you could potentially return the original thing and then have extension methods on that original thing that are BeginnerWait and endAwait. Let me just see. That's the last question I've got, so hopefully we're doing okay. So we can see we're doing something now. We've got things to compile, but nothing is actually happening asynchronously because we're always saying, nope, it's already finished. We already know that the result's going to be 5. So let's move on and have a similar thing now, but returning something. So previously our async method returned void. Now we're going to return task, and in fact we've got 2 async methods. One's going to return a task of t. And this time, again, it compiles, but this time the compiler support doesn't have void async method builder. It has 2 different types, async method builder and async method builder of t. And you can see that these are, again, required by the compiler. If we change these, it would no longer compile. These would obviously be provided by the version of .NET that you're using. But you can see they're a little bit more involved than before. Even the one which is effectively responsible for returning task just has a set result, set exception, and we've got to be able to get at the task that the compiler is going to return, the compiled code is going to return. And for task of t, well, we've got set a result, this time with a value, whereas this set result doesn't have a value. We've got set exception, which obviously is going to be called if an exception occurs, and task, which returns the task of t. Now, you may have noticed we're returning null from both of these. So if I run my program, we're going to call async method 1 and ignore the task that's returned. We're going to get the task of int from async method 2, but if we add a little diagnostic saying either task was null or task was not null, I'm pretty sure that when we run this, we'll say, aha, task was null. So that's one bit of output. We've also seen that we've got some extra results for in async method 1, which is within here, and in async method 2, and we can see set result being called. Initially, that's the one in the non-generic async method builder type, and here's the one that's in the generic one, and we can see what the actual result was, 15. We can see that result comes from the y plus 10. So just to remind you, all that we're looking at the moment, or rather the async method builder bit, is to do with the boundary between the caller code and the asynchronous method. It helps the compiler build something for an asynchronous method to return. It has nothing to do with the await statements. The await statements have everything to do with simple awaitable. Hopefully you can see now why I was very keen to break this up into the caller method, the asynchronous method, and the awaitable thing that we're going to await, and think about the two boundaries involved between each pair of those three things. Obviously the caller itself has no connection with the awaitable thing, so we don't need to worry about a boundary there. So all that's happening in the compiled code, behind quite a few hoops, is we're going to create a simple awaitable, call BeginnerWait on it, call GetAwaiter, then on the awaiter call BeginnerWait. That will return false. We'll then execute endAwait to get the result, and then we'll return. And only at this point will we actually return the task, because our simple awaitable never had to say it's going to finish later on. Hopefully our next one will. Let's see, real awaitable method. So our compiler support is getting slightly bigger. I've ditched the non-generic async method builder, so I think for everything else I've got, I'm only interested in generic versions, just because it's easier to concentrate on one thing. Everything else will work in a similar kind of way, just without any results. So in our main program, we're going to create a task by calling the asynchronous method, and then wait for it to get a result, and then give back the result. So let's see, our simple awaitable is exactly the same as before. So we're not starting up any threads, we're not going down the continuation path. All that we've changed in this project is we're going to make the task that gets returned from the from the asynchronous method to the caller method actually useful. In the previous project, we were returning null. So back in compiler support, we have a task completion source of t. This is basically a useful factory type that lets us build a task that we can later say, hey, here's the result. So you can imagine it potentially spinning off a new thread, going away, doing something else, and then when we get the result, we tell the task, or rather we tell the task completion source, here's the result, could you let anyone who is blocking on this task, let them know the result. So we've still got the same methods as before, create, set result, set exception, and task. But this time we're going to pass into the constructor for the private constructor for async method builder, we're going to pass in a new task completion source of t. And all that we do when we get set result called, we set the result in the task completion source. When we get set exception called, we return, we set the exception on the task completion source. And when we are asked for the task itself, we just return whatever the task completion source gives us. This is an existing type in .NET 4. Just to remind you, although I'm using the C# compiler from the CTP, I'm not using any other types from the CTP because there's no reference to async library. Okay? So this all exists today. And this time when we run it, we can see a result of 5, which proves that the program managed to get the right task back, that it could actually block, not that it needed to because we weren't spinning up any extra threads or anything. We can see that the result has actually come back. So that's to do with the async method and caller boundary. Everyone happy so far? Let me just see. I can't see many more questions. Let me just address these. Can you end a task if your app gets bored? You could apply a timeout to it, effectively, probably using composition, as I mentioned before. Do async tasks always run on the same thread, or can the framework decide to spin up another thread if deemed necessary? It's up to whatever we're awaiting on. So currently we haven't got anything that's creating new tasks, new threads rather. Potentially we could be doing, and later on we'll see, creating new threads, but that's all under the control of whatever we're awaiting. So nothing that the C# compiler does creates a new thread. That's really important to understand. It's all, that's down to the library code. Okay, let me just check and right. Yes, I will make the solution file available later on, by the way. Okay, so let's look at better tasks. Right. So now we're going to have a proper thing to await. So we've got a more extensive random main method, and we're actually going to do some things. I mentioned this before, task.factory.startNew. This is going to create a new task which will end up being run in the in a thread pool thread to compute a random number slowly. So in fact it uses a couple of GUIDs and then it sleeps for up to 3 seconds. So that's all that compute random number slowly does, and we're using the TPL stuff within .NET 4 to create a new task to run that on a different thread. And then we're going to try to await the first task, await the second task, and add the results. Now the interesting thing is here, task of T doesn't have a GetAwaiter method. So we need a way of getting a waiter. So we say garçon. That is the only pun in this talk, I promise. So this is an internal class. This is going to be our waiter. But we need something that's going to create a waiter for us, which is our extension method. So we have an extension method on task of T. Hopefully it looked like most of you are familiar with C#3, so you should be familiar with extension methods. So any task of T you can call GetAwaiter on, and it will return a garçon of T. And we're just going to call the garçon of T's constructor and pass it in the task. So just to remind you, we're talking about the boundary between the async method itself and the thing that we're awaiting, which in this case is a task. So the idea is we started up this task, we need to know whether it's finished or not and allow us to wait on it. So this is getting to be genuine, real asynchronous stuff, whereas before it's all been pretty much toys. So this is why BeginnerWait suddenly starts becoming a bit more interesting. So when we are asked to begin awaiting an action, we can look at our task. So we've stashed the task in the constructor. If the task is already completed, we return false, and things can keep going themselves. Otherwise, we say ask the task to continue with our action after we've finished. Now, we could potentially just pass in action. That creates an error. Oh yes, we need to pass in an action of task of T, so that the continuation that we pass to continue with gets told which task it's continuing, in case you want to pass the same continuation to multiple tasks. In this case, we don't care what task it was, because we already know, because we got it in an instance variable. So when the continuation occurs, we will call whatever continuation the compiler generated code originally gave us. And this doesn't take long at all. This is a non-blocking call, so it's just saying when we've finished computing these random numbers, please return. And sorry, please execute this callback. And we return true from BeginnerWait to say this is going to take some time. You can return to your caller now. I will run your continuation when things are finished. And then when the compiler generated code knows that we have finished, either because we returned false or because we returned true, but now we're in the callback, we get to see the result. And when they call end-await, we just return the result of the task. We know, assuming that everyone's behaving properly in terms of the generated code, we know that by the time end-await is called, we will have a result. So we can call task.result, and that will return quickly. So if we run this code, that is the startup project, we should see immediately we'll see main still running. So that shows that the main method gets to keep doing whatever it wants to do, which in this case is just blocking, and then we'll get the results eventually. We will also see two sets of this returning, because we started two different tasks to compute two different random numbers, and we've still got some debug things in here, so we'll see set result called with the two values as well. We'll see set result called with the one value, which is the sum. We will see, we don't have any more output, so we will just see the returning twice, and then the set result called once, and then the sum once. Fingers crossed. Yep, so each of the tasks returned, and at that point our async method was able to continue. It called set result on the task completion source that main was waiting on. Main was waiting on that one, the task completion source's task, and the main thread got to see the result. Okay, so now we're real async stuff now. Let me just check. I can't see any more questions, so I would assume that everyone's fairly happy now. Okay, let's get hairy. So far we've been building AsyncCTP, but we don't know what the compiler was really doing. Let's think about what it might have been doing. So here we're back to a really simple form. We've just got simple awaitable. We'll come back to our garçon later on. But what's the async method going to do with this? It doesn't know that we haven't got a complicated thing sitting behind us. It needs to still do whatever it takes just in case things do take a long time. So our manual equivalent, so this was handwritten code, but this is roughly what it does. So we're going to create an async method builder, because we're going to potentially need to return a task. Anytime that we hit an await, we may need to return the task. We're only going to return it the first time, because, hey, you can only return from a method once. But that could be at the first await. In this case, we've only got one await, but in our original introductory demo, it could be that the first task that we were awaiting fetching Stack Overflow might have finished before we got there, so that would mean we could continue and not return the task yet, but then when we hit the Google one, then maybe we'd have to return the task. So we create whatever's going to be required for this task, and then we see what's going on. So we're creating an awaitable that corresponds directly with this line here, and then we hit the await awaitable. So the await expression, we're aware, means we've got to call GetAwaiter, so we do, and we have to remember this simple awaiter so that we can call things on it. Now let's build the continuation that we're going to pass into BeginnerWait, and basically that says, ignore the try catch for the moment. When this continuation is called back, we want to get a value into, in this case, value 2, and the only reason I called it value 2 instead of value is because I've already declared a value later on, and that's, even though the value 2 occurs before in textual order, this value is still in scope here, so I can't have another variable of the same name, but they're logically the same variable. And at that point, we've executed this, logically executed this, so we can return, and return means calling setResult on our builder. We've seen that that's what happens before because we've seen that setResult gets called. All of this is in a try catch so that if anything goes wrong, which could be if this had more code in here, things could go wrong in here, or the end await itself could throw an exception if the task had thrown an exception. So if we were going back to our idea of fetching web pages, that could have thrown an exception if the host didn't exist or whatever. So the whole thing's in a big try catch. If anything goes wrong, we tell our task, our result, that that exception has occurred. Okay, having built the continuation, we can call awaiter.beginnerWait, and if that says that we've that things are going to take a long time, then we'll just return from the method knowing that our continuation will be called later. If it returns false though, which indicates this is already finished, we can just go ahead with the rest of our method, which is end await and set the result. And all of this is also within a big try catch block for exactly the same reason. If an exception happens, we want to set the exception on our task completion source, and as soon as anyone awaits the task, it will go bang. And if we reach the end of our method, we can return the task. That's the equivalent of getting to here without any of our await statements, our await expressions needing to actually be waited for. So if we call this, if we run this, we'll see they work the same way. Okay, let me see. It is now 9 o'clock. I'm happy to keep going. Probably for one more project would make sense. If anyone wishes to leave, then obviously, hey, you can leave at any time you like. I'm barely even going to notice. If there are any questions, if you'd like to ask now.
There aren't any new questions, but yeah, John, you can feel free to go as long as you like. And if people can't stick around, they can always watch the downloaded version on the DevExpress channel. Okay.
Well, I shall take 20 seconds to get myself some more water, which means I'll be able to go for longer. So think of some good questions. Write some questions while I'm getting water.
So yeah, everybody, if you can't stick around, the website is tv.devexpress.com. This should be available for download by Monday, March 7th at that website. And I posted that in the chat room, that link.
Right, okay, I'm back. So we have a question saying, could we run step-by-step project 6, which we've just run? So I'm assuming that the first version is okay, because that's exactly what we saw before. Let's run manual equivalent. Well, let's just step into it in the debugger. So note that this isn't an async task, so there's no magic auto-generated code going on. So when we run this, we'll see we create a builder, and we remember the task from that builder so that we can return it whenever we want to. We create our simple awaitable, and then ask that awaitable for an awaiter. Build the continuation. So note that this is a Lambda expression. We're not going to execute any of this code. What we're saying is this is what we want to be executed if we need to be called back. So if this is going to take a long time, then call back into here instead of continuing. We're then saying, well, pass that continuation in, and oh, it returned false because hey, it's just a simple awaitable. We're going to end await to get the result of that task, or sorry, of that simple awaiter. So that's going to be 5. And then we're going to set the result of the task. So if I look in locals and look at our task, we can see it's run to completion because I've set the result, and we can see that the result is 5. There's no exception, so we return the task. And now the main thread can block for the result, but we know there's already a result. Okay, just to answer the question, I'm definitely not going to go through as far as 12 because that would take us at least another hour. You'll see it gets very complicated in a minute. So I'm not going to do that, but I will make all the code available, and my plan is to write a blog series. Some of you may have been following the EduLink series. My plan is to go through all the code, this exact solution code, on my blog, probably 2 or 3 projects per post, and go through it all in considerable detail. So hopefully between that, any questions you have now and the recording, you should be sorted. If you do have anything, by the way, any more questions, hopefully we can put on the website details, but you can ask questions on Stack Overflow. That's always a good option because it means that the rest of the world gets to see the results as well. Or you can tweet me, I'm just John Skeet, all one word, on Twitter, or feel free to email me on skeet@pobox.com. Just search me, you'll find my email address incredibly easily. Okay, so hopefully that was enough of the manual translation. Now let's see what the compiler would do. So this is going to be for exactly the same. This should look very, very familiar. The async version, fine. Now the rest. Now I got this by running Reflector, and basically the Reflector code showed various unspeakable names, so names that won't be valid C# names. The same kind of thing that gets generated if you use an automatic property or a Lambda expression. All these kind of things end up with variables in your code like this. So you might have static int t angle bracket foo, and that's invalid code because you can't have angle brackets in an identifier, but the CLR is perfectly happy with it, so it's a good way of the compiler saying, right, this is my stuff, I get to mess with this. There's no way that you can have a naming collision, there's no way you can try to reference this directly other than via reflection. It's fine. So let's see, this is for some reason I've called it manual equivalent. It's sort of pseudo-manual in that I've looked at what the compiler actually built and translated it into vaguely readable code. So we'll see that the whereas in our really manual version we did everything within manual equivalent, in the compiler generated version we don't. We create an instance of a new generated class. So that's down here with lots of stuff in. We'll come to that. We're creating an instance of it and passing in 0, which is the initial state of this generated class. 0 means, well, 0 has 2 sort of meanings. It means either nothing's happened yet or I'm waiting for a result. And it feels slightly strange to me that it has those 2 meanings. I've got a Stack Overflow question about that, but I haven't had an answer yet other than, hey, it's a CTP. So we're creating this generated class, setting 2 properties on it, or in fact I think they're just straight fields. So one is the move next delegate, and this is going to be used later on as the continuation. And we're setting it via a method group conversion to the moveNext method. So we'll see down here we've got a moveNext method. So if you remember earlier on, I mentioned that things were very similar to iterator blocks. Well, moveNext sounds awfully like IEnumerate or t.moveNext, and it's basically a lot of the same C# compiler code is used for both. So we're setting the moveNext delegate, we're setting the builder, so this is the builder of the asynchronous task. So this is to do with what we're handing back to our caller. We then call moveNext synchronously once, so that may or may not get to the end of all our actual logic, just as in our manually generated code you could end up hitting the normal return statement if everything we await was already done. And whether or not this actually gets to the end of the real logic, this will return at some point. It's the void method, but however it's returned, whether it's because we've hit an await that's going to take a long time, or because we've sailed through the whole thing, we're just going to return the task to the caller. So that's the only thing that returns the task at all. Okay, hopefully that bit is clear. Now let's look at the generated class. So I've extracted the variables into a few different sections. We have these fields here for the delegate and the builder. We still need the builder within the generated code because we've got to have something to call setResult on. We've returned the task already, but we need to be able to call setResult and setException. Now we have some instance variables that are the equivalent of the local variables in our original async method. So let's just go back and look at what that async method was. It was compute async with var awaitable and int value. So we've got two local variables here. One, this var is actually equivalent to simple awaitable, called awaitable, and value that's an int. So we've got these two local variables. We've got a couple of temporary variables. So we know that we're going to need an awaiter at some point, and we've still got to be able to get at the awaiter again when we're called back. And we're going to be called back by going straight into this method. So we better be able to keep the state somewhere. And the idea is that this generated class keeps all the state that we need. Temp is going to be used to store the result of end await before we then do with it whatever we need. So here we're actually, in this case, we're assigning it straight into value. So in some ways we don't need the temp variable, but if you imagine a couple of attempts ago, we awaited two things and stored them nowhere really. We would await one of them, and then when that had finished, we've sort of got it in our hand while we wait for the second one. Well, got it in our hand isn't something we can really tell the compiler. We need to store that somewhere until we're done with it, and we would store it in a temporary variable. So when the, excuse me, sorry, my doorbell's just rung, I'm just going to ignore it. We've got the temporary variables, and then we've got some state that is common to all asynchronous methods. Will have these three variables. So state tells us where we've got to. Disposing tells us whether we're in the middle of disposing, and I haven't actually found a use for this yet. This could be vestigial from what we're doing with IEnumerate. And do finally bodies we will see later on in the more complicated code. So let's see what we get to do in this class. In the constructor, it just remembers that we're at the start of the method. In dispose, we remember that we're disposing, which nothing's actually going to notice, and call moveNext, which presumably, if we had anything that we needed to dispose of, moveNext would do the disposing. Excuse me for just a second. Hello. Yeah. Yes, I can't talk to excuse me for that. Right, I'm back. So when move next is called, this will happen either initially, so within our original method that the caller gets to see here, within the main thread, or it also gets passed in as the continuation. So it's a sort of multifunctional thing. It needs to basically pick up from wherever we got to, and including potentially, if anything ever called dispose, which I don't think it does, we would get to here. So within move next, we need to take account of where we've got to and do the next thing. That's all it needs to do. So you can think of move next as do the next thing. Right, first we remember if we've got any finally statements, any finally blocks, we need to remember to do them because we're properly in the method now. And we'll see there's a finally, well, we don't have any finally blocks in this case because there are no finally blocks in the original. But if we did, then the finally block would say, well, do we really want to do a finally or not? Because remember, we're going to return from this method potentially in just a moment. And in fact, we say if we're not in state 1, which we're not, we're starting off at state 0, then if we're at state -1, which we're not, then just return. So state -1 means we're finished, we're done. So if we're ever called again when we've got to the end, then we're done, you don't need to do any more work. Otherwise, so in our initial state, we will get as far as here, run this line of code, so this exactly corresponds with our original async methods, awaitable equals simple awaitable. Note that we don't need the variable declaration because it's an instance method. Then we're going to get an awaiter. So the next statement from the async method was await the awaitable. So here we create the awaiter. Remember that we've got to the first await statement, await expression. Now we're going to say, if we return from here, we don't want to do any finally work. Not that we've got any to do, but if you imagine, logically, we're pausing. We're not logically returning as far as the async method is concerned. Okay, so logically, as soon as this is finished, we're going to go on to the next statement. We're not returning yet. So imagine this was in a try stuff, finally other stuff. Okay, if the await statement, if the await expression causes us to return from move next, we don't want to execute this bit because logically we're just paused at this point. So that's what the do finally bodies is all about. We'll see it in a minute on the more complex translation. Okay, so we know that we've got as far as the await one, the first and only await. If that returns true to say, yes, you need to wait and come back later, I will call your continuation, which just as a reminder is move next, then we can just return. We're done, the caller can see the task, can wait for the task later on, and we're fine. Otherwise, so if the awaiter.beginnerWait call returns false, that means no need to wait for this awaitable, it's already done, you can ask for the result now. We go back into saying, okay, if something happens now, we do want to execute some finally bodies. Either way, we end up at this point. So remember that all of this was in a big if state not equal to 1. So obviously if beginnerWait returns false, we will drop down here and drop out of this if block. But also if this had returned true and we'd returned, our state would be 1. When the continuation executed, it would come into here, get to if state not equal to 1, oh, state is 1, so let's ignore this if block, come back to here, and then call end await. This is the clever bit. Okay, so the idea is we've managed to get to this end await statement either synchronously if BeginnerWait returned false, or asynchronously via a continuation which remembered where we were in our state machine if BeginnerWait returned true. At this point, if I were in front of you as a live audience, I would be asking you to nod your head if you're basically following where we're going. I will just have a quick look. I'm not seeing anything saying that people's heads have exploded. Yeah, and in fact, people are nodding. Hurrah! Good. Okay, so now we've got to the end of the difficult bit for this one. So we end await, set the result into temp, and hey, the next thing we need to do is assign that into value. Remember that we've got to the end of our asynchronous method and set the result. We're done. If anything had ever gone bang, we would remember that we were done and set the exception on the builder so that that exception could be propagated. And that is the, let me just see how many lines this is. So if we include from there, line 25 down to about there, line 100, so that's 75 lines of code generated for, well, let's be generous and say 6 lines of asynchronous method. Now the bad news is that was the easy version. Someone's just asked why we need the temp variable again. Imagine that wherever there's an await, there's an actual int temp equals await bit. So it's to retain the state because we may not be assigning it straight to another variable. In this case we are. In other cases, like here, we actually used it in an addition, and because we wouldn't be able to get the other bit immediately, we have to have some sort of temporary storage. So maybe in a future version the compiler will optimize to say, well, if we're just doing an assignment, then we can do the assignment straight away. Now I hope you'll agree that was a reasonably simple asynchronous method that we were compiling. Let's do something a bit more complex. So our asynchronous method is going to do lots of things. We're going to create 4 awaitables. Again, just simple awaitable. So these are never actually going to create any threads. We're going to have a total local variable, and then we're going to await each of these in turn and write the results to the file and remember what we've seen as the total, have another await expression and get things from a different place, and we will return the total. So if I remember rightly, each of these is going to return 5. We've created 4 simple awaitables here. So we will have a file called values.txt with 4 lines saying received value 5. We'll await one final one and return 25. Hopefully. Yes. Hurrah. Okay. Now notice that this time there's a using statement which we're going to use to clean up after ourselves. Now normally that's fine. Effectively you can see the nesting within here. Think of that as being a push into the stack, and when you come out of the stack, then we've got to clean up after ourselves. Well, that doesn't really work when we're going to await in the middle of this, because we're going to have to return from our method, effectively putting this method on pause. As you can imagine, when we pause, we don't want to close the writer. If you remember, there was all this stuff about do finally bodies. So the do finally bodies will be set to false at the point that we're awaiting so that we don't close it too early. Let's have a look at the generated code. It starts off in the same way as before, and this is actually what every async method gets generated as. Just create an instance of the generated class, set the continuation, set the builder, call the continuation effectively once and return the task. This is the mess that gets generated for us. And the fact that this is a mess is why you should be very grateful that the compiler is doing it all for us. So it has a bunch of local variables. Sorry, it's got the normal boring builder and move next delegate. It has local variables we're aware of, awaitables. Now, because we're using a collection initializer here, that actually isn't equivalent to creating a new list and then calling add on it. Sorry, creating a new list, assigning it to awaitables, and then calling add on it 4 times. It's got to create the list, call add 4 times, and then assign the result into awaitables, which is why we've got a little collection initializer target first. Because we're going to iterate over this, we need an enumerator. We need our writer, our awaitable, value, total, and other. They are just totally normal ones. So the only ones of these that we aren't normally aware of are enumerator and collection initializer target. Okay, I see a question saying that someone's head hasn't exploded. Just wait, it's coming. And we've got two other pairs of temporary variables. So every time we have an await expression, we get one variable representing the awaiter and one variable representing the result. That's assuming there is a result. I haven't checked, but my guess is if we were awaiting just a plain task where the end await is going to be void, I would certainly hope that we wouldn't have this extra local variable, sorry, this extra instance variable in the generating task class rather. We've still got this disposing. For those of you who don't happen to know error codes off by heart, 0414 is the warning, this is never used. It will always have its default value, nothing's going to, in fact it's never read. It's always going to be set to something if you call dispose, but nothing's ever reading it, so it's boring. But this time do finally body is going to be read. I will whiz through this in head exploding speed because I've done this before and it takes about 25 minutes, half an hour to do in detail. You'll be much better off waiting for a blog post, particularly as my voice is going. So this time, our state, we don't just have an if state not equal to 1, we've got to get to roughly the right point to start with, so we're going to switch on state, and if it's 1, we're going to break out and go to the next thing. If it's 2, we're going to go to a separate label. For those of you who weren't aware, yes, we do have goto. So go to after final await, yep, right near the end. So state 2 is going to be, well, as I've named it, after the final await, when we're ready to deal with the results of that final await. -1 means we're done, and the default, so that's 0 in this case, is going to be if we're coming into this to start with, then we need to go through all this initial setup stuff. So we call create text, but we haven't started the loop yet. But we will fall out to this end of brace, and we'll also fall there if we're in case 1. So 2 and -1 go to different places, but 1 and 0 end up here. We're then going to take our current state. If we're already in state 1, so we've come back due to an await, then, sorry, well, if it's not 1, for instance, if we're doing it to start with, then we need to start looping, which means calling GetAwaiter. Otherwise, we've got to work out, and again, if we're not in state 1, so if we're plodding our way through the first time, we're going to go to after first await. Sorry, do excuse me, I got that round the wrong way. If it's not equal to 1, so if it is the first time, we're going to go to the start of the loop condition, which is right down here, and says, well, if there aren't any items in our list, then we're done. But if there are, we will go to start of loop body, at which point we fetch the first item, effectively, but the current one in the enumerator. Get an awaiter for that. Remember that we've got to an await statement, an await expression. remember that we don't want to do the finally bodies, and BeginnerWait. So at this point, if we've been following through everything that's happened, we have run through the collection initializer, we've set the total to 0, we've opened the text file, we've started doing the for each, and we've hit this await. And the idea is we need to be able to get back to the end of the await, which is what happens if we're in state 1. So let's imagine that our BeginnerWait method has returned true. So it's going to take a while to wait for this to finish. So we're going to return from the method so that the caller method gets to see our task. And then we'll come back into here. How do we come back in? So we want to end up coming to the same place as we would if BeginnerWait returned false, which is basically this. So label after first await. But we'll be coming back in with a state of 1. So in we come, our continuation runs, do finally bodies is true, case 1, break, okay, out we come. If the current state is not equal to 1, well it is, so let's ignore that. So we'll try here, if the current state is not 1, go to start, no, that's not relevant to us. Go to label after first await. And we're back to where we wanted to be, hurrah! See the various contraptions that the C# compiler needs to get us back to the same place, whether we took the slow path, i.e. via the continuation, or the quick path, where it said, hey, you don't need to wait for this to finish. Either way, we call endAwait to get the result, write it to the text file, add it to the sum, and keep going. And keep going means check whether there are any more. If there are, go back to the start. So let's imagine that we've done that 4 times. Sometimes it might take continuation, sometimes it might not. We'll come out of this loop. So we've actually got, even though we've got 1 using statement, we've actually got 2 finally bodies here, because for each always adds a finally body as well to say I want to dispose the iterator now. So that's why we've got this if do finally bodies dispose of the enumerator, and this is the finally block corresponding with the using statement. If we're meant to be doing finallys and the writer is non-null, then dispose of the writer. So we've now effectively got to after the loop. So we now have simple code for a single line, which is create the simple awaitable. Then we need to get the awaiter for it, and again we're into the we need a continuation so that if the BeginnerWait returns true, we want to get back to here. If the BeginnerWait returns false, we will just fall through to here. So again, let's just imagine it. We've returned from here because BeginnerWait has returned true. We come back in, move next happens when the continuation gets mentioned, gets called. We go to case 2, go to label after final await, then that's awfully reminiscent of, yeah, where we just got to. So either way, slow path or long path, we've got back to the right place. We call endAwait, we up the total, we remember that we're now done, and we set the result saying return. And if any of this fails, we set the exception. Okay, I will take some questions. I think I will leave everyone's heads to simmer at that point, because frankly, I can't remember all this from day to day. I have to sort of make it up as I go along, so my head's fairly steaming as well. Okay, let's have a quick look at some questions.
I don't know if you have, let's see, you have some comments, I guess. Looks like the user side is easy to get used to when you get the 3 components of setting up the async stuff.
Okay, we have async functions as first-class citizens. I'm not sure what counts as a first-class citizen, to be honest. But an async method is first-class in terms of it supports most of what you can do in a synchronous method. I'm sure there will be things that you can't do in an async method. I don't think details have been given of that yet. But think of the ability to write an async method as the important bit. And what you do in an async method is use await, and that doesn't have to be awaiting an async method call. It can await anything that's awaitable. So it's the ability for an async method to usefully return a task that something else could await, and also consume things by awaiting them. It's that sort of dual nature that's useful. Okay, what else was there? Reminds someone of coroutines. Absolutely. A lot of this is quite coroutine-y. So the idea of coroutines is it's a grotty hack way of effectively pausing with some state. That's what state machines are like. And
a lot of head exploding.
Yep, good. That was all the questions that I can see at the moment. I will stick around for a couple of minutes in case anyone else has any, but otherwise do feel very, very free to ping me an email, ask me on Stack Overflow, or rather ask on Stack Overflow. It may not be me that answers. Who knows?
Hey John, do you have your email on a card, or can I post it in the chat room for you?
You can certainly post it. I'll write it in the comment here. Email skeet@gearbox.com. But as I say, if you search for me, you'll find my email address very easily. I tend to put it in all my public profiles because I figure I'll have to deal with spam either way. So I might as well make it easy for people who are useful people to get in touch with me as well as the spam.
Awesome.
So I should just say this is the first time I've done a webinar, so apologies for any slight confusions and amateur mistakes. That's the kind of thing that I do. So hopefully I'll get better at this. And
no, it was.
Thank you very much.
I thought it was great. I think most everyone would agree. It's the question. You got a lot more questions, I think, than we anticipated. But other than that, that's not a bad thing.
I think that it's a case of if you haven't seen any of this stuff before, then seeing the details of how it all behaves are really quite tricky. So
right.
That's why I decided to spend quite a bit of time on the introductory demo, having seen the poll of how many people had actually used this, almost no one. So even if you'd seen a video before, hopefully the introductory demo just reminded you of what was going on. So note that very little of what we did today dealt with creating new threads or handling exceptions or handling cancellation, all kinds of different things. The next 4 projects would have handled a little bit of that. So hopefully it'll go on the blog.
Great. You've got a lot of thank you comments, but no further questions.
Oh, blog URL.
Yes.
Yep, I'll give that now. So yeah, again, if you search for John Skeet blog, you'll find me.
Okay. Okay, well, with that, I guess we'll say thank you very, very much, John. Excellent webinar. We'd love to have you back at any time.
Absolutely.
Obviously, you can keep going. And people would like to see it. So thank you for being here.
Thank you. My pleasure.
All right, everybody, we have several webinars coming up next week. You can visit devexpress.com/webinars and register. Here's a quick peek. Next Monday, March 7th, Julian Bucknell, our CTO, is back with JavaScript 3. He continues a series of webinars that teach you the basics of writing JavaScript. This webinar will concentrate on functions and assumes that you've watched parts 1 and 2. If you haven't watched parts 1 and 2, you can visit tv.devexpress.com and check them out. Tuesday at 10 a.m., DevExpress welcomes Franz Buma with Solutions Design presenting reporting with the LLBL Gen Pro Runtime Framework. This session will focus on using the LLBL Gen Pro Runtime Framework in conjunction with the DevExpress reporting suite. And also Tuesday at noon, using CodeRush in MVC. Mark Miller and Rory Becker show you how to accelerate your MVC development with CodeRush. We have a great lineup of webinars scheduled every day next week and throughout the month of March. Visit devexpress.com/webinars and register away. Again, if you missed anything from this webinar or you want to review any previous webinars, visit us on the DevExpress channel at tv.devexpress.com. Again, thank you so much to John Skeet. Thank you all for joining us, and thank you for choosing DevExpress.